Hello viewers, today we start lecture number 5th on eccentric connections. In this lecture we learn about second type of welded connections, that is plane of movement at right angle to the plane of weld. Figure first shows such type of connection, and this connection is subjected to shear and bending due to the load P. Remember that this connection is subjected to shear and bending. We have provided H height of the fillet weld. This is height H. This is H height. We have to provide fillet welding is done on both vertical side. We also done all around the edges of the bracket, but in this case we have to provide welding on both vertical sides. Then we have to calculate effective area of weld, that is length of weld multiplied by effective throat thickness, that is 2h into t. Our first step is calculate the direct shearing stress, that is Q equals to P upon effective area of weld 2h multiplied by t. In the second step, we will find out the bending stresses on the weld as a result of load P and its eccentricity. As we are aware of that formula, F bending stresses is equals to bending moment upon section modulus. Here moment M equals to P multiplied by eccentricity, and section modulus is I upon Y, that is TH square upon 3. Therefore, bending stress F is given as F equals to M upon Z 3P into E upon TH square. In third step, equivalent stress Fe equals to bending stress F square plus direct shearing stress to a square multiplied by 3, that is F square plus 3Q square under root of F square plus 3Q square. Then we calculate equivalent stress with the design strength of weld. Now we compare that equivalent strength with the design strength, that is Fu upon gamma m naught multiplied by root 3. If equivalent stress Fe should be less than equals to design strength of weld, then the analysis and design of the weld is termed as satisfactory. Next step, we will find the height of weld. Height of weld equals to height of weld due to bending resistance and plus height of weld due to shear. This is height of weld due to bending resistance plus height of weld due to shear is 10% of height of weld due to welding. Therefore, total welding height is 1.1 multiplied by under root of 6m upon twice t into yield strength of weld. Now we take one example. Design a suitable fillet weld for the bracket as shown in figure second. If working load equals to 200 kN and eccentricity E equals to 200 mm, the thickness of the bracket plate is 12 mm and the column uses ISHB 300 at the rate of 63 kg per meter. First step in solution is there is given working load equals to 200 kilonewton is given, so we calculate factor load, that is 1.5 into 200 equals to 300 kilonewton. In second step, from structural steel handbook or steel table, we have to get thickness of flange, that is 10.6 millimeter of ISHB 300. Therefore, we calculate maximum size of weld is 9.1 millimeter and minimum size of weld as per table number 21, it comes out to be 5 mm. So we have to provide size of weld between 5 mm to 9.1 millimeter. Hence, use 8 mm size of weld. In third step, we have to calculate effective throat thickness, that is T equals to 0.7 into weld size. Here we assume the K value equals to 0.7. Then effective throat thickness comes out to be 5.6 millimeter. In fourth step, we have to calculate strength of weld per millimeter length. Design strength multiplied by area of weld, that is weld length multiplied by throat thickness. The strength of weld per mm length comes out to be 1060.47 Newton per millimeter. Then we have calculate height of weld. This height of weld is calculated by the formula 1.1 multiplied by 6 into m upon twice into per mm strength of weld, that is 1060.47. Hence height of weld comes out to be 454 millimeter. As we know that permissible stress in weld is Fu upon gamma mw into root 3, that is 189.37 Newton per mm square. Now in next step, we apply the check for stresses. We have to calculate first direct stress, Q equals to P upon 2H multiplied by T. Direct shear stress is 59 Newton per mm square. Similarly, bending stress F equals to 156 Newton per mm square. Then from both these stresses we calculate equivalent stress. It comes out to be 186.5 Newton per mm square. And the design strength of weld is greater than that, so our weld is safe. This is exercise. You have to perform this exercise.